So let's take a look at volumes by cylindrical shells, otherwise known as shell method. Now keep in mind that shell method is just another way to find volume of solids, similar to the disk and washer method, and shell method is kind of going to be the opposite of disk and washer. So in disk and washer, when you rotate it around the x-axis, you'll use x variables, but in shell method, if you rotate around the x-axis, you'll actually use y variables. And if you're rotating around the y-axis, in shell method, you'll use x variables. Now the formula for the shell method, the volume is going to equal 2 pi times the integral from a to b of x times f of x times dx. And once again, we're using x variables because we're rotating around the y-axis. However, if we're going to rotate around the x-axis, then we have to put everything in terms of y. So the formula is going to be 2 pi times the integral from c to d. Once again, those are y bounds of this time y times f of y dy. Now in the formula, a and b are obviously our bounds, 2 pi is just a constant. Now f of x is just going to be the given function, and x acts as the radius from the axis of rotation to the curve. So for this first problem, we need to find the volume of the solid obtained by rotating the region bounded by the given curves about the y-axis. So for number 1, we have y equals e to the negative x squared, y equals 0, x equals 0, and x equals 1. So let's start by graphing these curves. So if you use your calculator and graph y equals negative e to the x, or e to the negative x squared, it's going to look something like this. And then y equals 0 is obviously just going to be the x-axis. We have x equals 0, which is the y-axis, and then we have x equals 1, which is somewhere around here. So this is the region we're talking about, and we want to rotate this region about the y-axis. Now with the shell method, because we're rotating around the y-axis, we're going to use x bounds. So the formula, once again, the volume equals 2 pi times the integral from a to b of x times f of x dx. So if we go ahead and fill in our information, volume equals 2 pi times the integral. Now we are using x bounds once again. So our x bounds range from x equals 0 to x equals 1. So our bounds go from 0 to 1. Now x is just going to be the radius, that is the distance from the axis of rotation to the outermost part of the region that travels an x distance, or a distance in the x-axis, so we just label it as x. And then f of x is just the height. In this case, that's going to be the function itself, e to the negative x squared. So we have the integral from 0 to 1 of x times e to the negative x squared times dx, and then we can go ahead and evaluate the integral. Now in order to evaluate this, we can just use u substitution. So if u equals negative x squared, then du, or the derivative of negative x squared, is negative 2x dx. If I isolate dx, dx equals du over negative 2x. If I go ahead and plug in everything back into the integral, we have 2 pi times the integral from 0 to 1 of x times e to the u, because I made u once again negative x squared, and then times dx, which is equal to du over negative 2x. So times du over negative 2x realizes the x's will cancel. A negative 2 or negative 1/2 can come outside of the integral. So then we get 2 pi times the negative 1/2 times the integral from 0 to 1 of just e to the u du. Now the 2's will cancel on the outside, so all we have left is negative pi. So I can simplify this to negative pi as the constant outside of the integral. And then the integral of e to the u is just going to be e to the u. And then I can go ahead and replace or substitute back in our u. So we have negative pi times e to the negative x squared. So if I rewrite that down here, negative pi times e to the negative x squared, and we can now evaluate our integral from the bounds of 0 to 1. Negative pi, once again, is just a constant, so we have negative pi times, when I plug in 1 for x, we get e to the negative 1 squared, or e to the negative first, minus, when I plug in 0 for x, we have e to the 0, which is 1. So then that's going to be the final answer here. I can just distribute the negative if I want to, and rewrite it as pi times 1 minus e to the negative first, or 1 minus 1 over e. Now for the second problem here, we have almost the same problem, but this time we're going to rotate about the x-axis instead of the y-axis. So notice that we have to put everything in terms of y. So our given curves are x equals 1 plus y squared, x equals 0, y equals 1, and y equals 2. So let's start by graphing these. Now for x equals 1 plus y squared, I'm going to just isolate y first. So I'm able to graph this curve. So y squared equals x minus 1. So then y equals plus or minus the square root of x minus 1. Now let's just focus on the positive version. y equals positive square root of x minus 1. Well, this is just the square root of x graph, but shifted to the right one. So it's going to look something like this. And the negative version is just a reflection across the x-axis. So it looks something like that. Now we have x equals 0, which is going to be the y-axis. We have y equals 1, which is going to be somewhere around here. And then we have y equals 2, which is somewhere around here. So we're basically looking for this region. This is the region that's being bounded by all four of those curves. And we want to rotate that region about the x-axis. Now once again, the formula for shell method, this time we're putting everything in terms of y, because once again we're rotating about the x-axis. The volume equals 2 pi times the integral from c to d, once again those are our y bounds, of y times the function f of y dy. So if we're rewriting the formula, volume equals 2 pi times the integral. Now our y bounds go from 1 to 2, so our integral is going to go from 1 to 2 of y, because that's going to be the radius or the distance from the axis of rotation to the outermost region of the curve. That's going to travel a y distance, so that's going to be y, and then times f of y, the function itself. In this case, the height of the function is going to be the function x equals 1 plus y squared. So we multiply y times 1 plus y squared, and then times dy. Now simplifying what's inside the integral, we have 2 pi times the integral from 1 to 2. I'll distribute the y, so y plus y cubed times dy. So now we have 2 pi times the integral of y, which is y squared over 2, plus the integral of y cubed, which is y to the 4th over 4. And then we can go ahead and evaluate from the y bounds of 1 to 2. So we have 2 pi times, when I plug in 2 for y, we have 2 squared, which is 4 over 2 is 2, plus 2 to the 4th is 16, 16 over 4 is 4, minus when I plug in 1 for y, 1 squared over 2 is 1/2, plus 1 to the 4th over 4 is 1/4. So we have 2 pi times, now 2 plus 4 is 6, minus 1/2 plus 1/4. I'll change 1/2 into 2 over 4. So 2 over 4 plus 1 over 4. Then we'll get 2 pi times 6 minus 2 over 4 plus 1 over 4 is 3 over 4. Now in order to combine 6 and negative 3 over 4, I'll have 2 pi times, I'll rewrite 6 as 24 over 4 minus 3 over 4. So then we have, I'll write up here, 2 pi times 24 minus 3 is 21. So we get 21 over 4. Now 21 times 2 is going to be 42. So we have 42 pi over 4, which will simplify down to 21 pi over 2. And that's the final answer. Now for number 3, we have y equals x squared, y equals 0, x equals 1, x equals 2. And this time we're not going to rotate about the x or y axis. We're going to rotate about x equals 1. Now x equals 1 is a vertical axis, similar to the y-axis, so we put everything in terms of x, and we use x variables when we use shell method in this problem. So if I go ahead and graph out these curves, we have y equals x squared, we have y equals 0, that's going to be the x-axis, we have x equals 1, and then we have x equals 2. So basically the region we're looking at is somewhere in between here. And we're going to rotate this region about x equals 1. So about this line. Now the shell method formula once again is volume equals 2 pi times the integral from a to b of x times f of x dx. And so rewriting the formula, we have 2 pi times the integral. Now our bounds range from x equals 1 to x equals 2. So our integral is from 1 to 2. And then we have our radius. Now be careful here, because we're not rotating about the x-axis or the y-axis, we're rotating about x equals 1. So whenever you rotate about a line that's other than the x or y-axis, similar to the disk and washer method, you have to do the line minus x, or line minus y, depending on whether you're rotating around a vertical or a horizontal axis. Since we are rotating around a vertical axis, and everything is in terms of x, we're going to take the line minus x. So our radius is going to be the line x equals 1, so 1 minus our variable x. And then we multiply by f of x, which is the function itself. That is y equals x squared. So we multiply by x squared, and then multiply by dx. Now before I evaluate the integral, keep in mind that you should only use shell method if disk and washer do not work first. So in this case, if you use disk and or washer method, Now, obviously, if you use disk method when you're rotating around the y-axis or around the vertical line x equals 1, that would not work because our volume formula would be pi times the integral from, obviously it's still going to be from 1 to 2, those are our x bounds, but our radius squared, this time our radius just ranges from 1 to 2, so our radius would be 1 times dx. Well, this is a completely different formula than this one, so disk method would not work in this case, nor would washer. Now, however, if you were to rotate this region around the x-axis, then you could use disk method. This would work, and you wouldn't have to use shell method. So once again, keep in mind that shell method should only be used if disk and washer do not work. So simplifying the integral, volume is going to equal 2 pi times the integral from 1 to 2. I'll distribute the x, so we get x squared minus x cubed times dx. So then we have 2 pi times the integral of x squared is x cubed over 3. And then minus the integral of x cubed is x to the 4th over 4. And then we can evaluate from the x bounds of 1 to 2. So we have 2 pi times, when I plug in 2 for x, we have 2 cubed, which is 8, so 8 over 3, minus 2 to the 4th is 16 over 4 is 4, minus, when I plug in 1 for x, we have 1/3, and then minus 1 over 4. Now, in order to find common denominators here, I'll rewrite 4 as 12 over 3. I'll rewrite 1/3 as 4 over 12, and I'll rewrite 1/4 as 3 over 12. So then we have 8 over 3 minus 12 over 3 is going to be negative 4 over 3. We do have a 2 pi on the outside, and then we have minus 4 over 12 minus 3 over 12 is 1 over 12. Now I'll rewrite negative 4/3 as negative 16 over 12. So then we have 2 pi times negative 16 over 12 minus 1 over 12 is negative 17 over 12. So then we have 2 times negative 17 is going to be negative 34 pi over 12. And then I can simplify that down to negative 17 pi over 6. Now notice that we got a negative answer for volume, and obviously volume can't be negative, it has to be positive. And the reason why that is if we look at the graph here that we drew earlier, the region is to the right of our axis of rotation. And in this case, our axis of rotation was the line x equals 1. And if the region is on the right of the axis of rotation, you could have also put x minus 1, and you will get the positive answer, so positive 17 pi over 6. However, we just did the line minus x, so 1 minus x, and then we got the negative answer. And that's just a small mistake, it doesn't necessarily matter, but just make sure that if you get the negative version of the correct answer, just make it positive, and then that will be the correct answer. So to reiterate one more time, if the region is to the right of the line of rotation, then you would put in the form x minus 1, because x is the radius and 1 is going to be that line of rotation. However, if the line of rotation is to the right of the region, or in other words the region's on the left side of the line of rotation, then you would put 1 minus x and we would get the positive answer. However, if you don't remember that, that's fine. Just remember to take the line of rotation minus the variable, and you'll sometimes get positive answers, you'll sometimes get negative answers. Just make the answer positive and you will have the correct answer if you did use the correct formula for shell method.